You might find it hard to believe, but with gold prices being so high these days, could we try refining high-purity gold from gold ore right at home? Take this seemingly unremarkable dark stone for example. If you saw it lying by the roadside, you probably wouldn't give it a second glance. But if you mastered the true art of turning stone into gold, this rock's value could easily reach several hundred thousand. This stone is about 533 grams. Next, let's test the gold content. We'll cut off a small piece and place it on an electronic touchstone, adding a few drops of a specialized testing solution. The reading shows approximately 10K. For comparison, when a genuine 24K gold ring is placed on this device, all the lights light up, indicating a high gold content. A 10K rating means about 41.7% gold purity. Multiplying that by the total weight, we could potentially extract around 222 grams of gold. However, there will inevitably be some loss during the refining process, so let's see how much we can actually get. The first step is to prepare a dry wok, because, as the saying goes, true gold withstands fire. In traditional alchemy, the roasting method is the simplest and most fundamental way to process gold. Gold ore, as the name suggests, is a stone composed of gold and various minerals. During the burning process, some impurities like flux and other gaseous substances will volatilize directly. Meanwhile, other solid impurities will melt into a liquid state if the temperature is high enough. After melting at high heat, quickly pour the liquid ore into cold water, where the different materials will coagulate. Afterward, you'll notice the stone now has a golden, lustrous surface, far from its original dull appearance. Since we're aiming for high-purity gold, we can repeat this process a second time. After this melt, prepare a larger bucket, slowly pour the liquid in, and let it solidify into small chunks for easier processing later. Each step is designed to yield higher purity gold, though the weight will naturally decrease. Collect all these smaller chunks, place them in distilled water, and heat them to isolate floating debris and impurities. Strictly speaking, at this stage, all the solids still contain gold. Even the black impurities on the filter paper in the funnel are gold-bearing and shouldn't be wasted. Rinse them with water to clean them up. The most troublesome part of the refining process is dealing with these scattered, granular bits. They contain gold but can't be discarded. At this point, the larger granular ore pieces are already thoroughly cleaned, leaving behind the black powder and solid fragments. So, how do we refine this portion? The method is quite simple. Bundle up the entire filter paper, place it back into the dry wok, and use high heat to melt away more impurities. With sufficient heating, you'll eventually obtain a solid, metal-like substance. This solid has a very high gold content, while the impurities remain in the wok. Surprisingly, the solid collected from just these powders weighs over 10 grams. This completes the roasting phase, removing a portion of the mineral impurities from the ore. Next comes the most critical step, separation and purification. At this point, let's measure the remaining material, about 515 grams. This purification step requires some chemical reagents. First, add 3 parts hydrochloric acid to the solid, followed by 1 part nitric acid. When these two acids are mixed, they form a substance with an official name, aqua regia. The recipe for aqua regia is straightforward, but it is also extremely dangerous. A warm reminder, this video is for demonstration and educational purposes only. Please do not attempt it at home. Aqua regia was developed primarily to dissolve metals that are difficult to break down, such as gold foil and other precious metals. A quick note here, dissolving and melting are two different concepts. Melting turns a substance into a liquid state, while dissolving breaks the metal down into particles, commonly known as gold powder. This decomposition step relies on the strong acids in aqua regia to break the metal into these particles, which we'll separate later. However, the separation process doesn't seem to go as smoothly as expected. After aqua regia corrosion, the larger particles don't become as fine as hoped, so we'll need to heat it again and repeat the separation. This process takes some time, and heating can accelerate the chemical reaction. After sustained heating, you can see that the bottom of the cup is now filled with very fine particles. Pouring out the liquid reveals that the bottle's base is now covered with gold mud. The purity of this gold mud is already quite high, but what about the gold powder dissolved in the water? This calls for the third step, reduction. The reduction process requires another chemical, sodium metabisulfite. After adding sodium metabisulfite to the gold solution and allowing it to settle, the gold powder will all sink to the bottom of the beaker. After multiple filtrations to separate the solids from the liquids, we collect more and more gold mud. The next step is purification. The purification method is similar to the second step. Dissolve the collected gold mud in aqua regia again. This time, the liquid's color is noticeably different. Isn't it getting closer to the hue of gold? At this point, you'll notice solid gold forming at the bottom of the beaker. With this high-purity gold solution in hand, the following steps become much simpler and easier to handle. The next task is to separate the gold from this gold solution, essentially repeating the third step of reduction. Add some sodium metabisulfite to the solution, and you'll see the gold powder clearly precipitating downward. However, one final issue arises. How do we know when this gold solution has fully precipitated all its gold? This is typically resolved using chemical reagents. Mix hydrochloric acid and stannous chloride in a specific ratio to create a test solution. Dip a piece of paper into the gold solution and add a drop of the stannous chloride solution. If the solution darkens, it indicates a high gold content remains. In that case, continue adding the reducing agent. However, the reduction process requires time for the reaction to complete. After adding a sufficient amount of reducing agent, the next step is to wait. After a few hours, the solution begins to clear. The liquid on top looks very transparent, while the solid at the bottom increases. At this point, test it again. Although the water still has some color, the reagent shows no reaction when added, indicating that the gold content in the water is now nearly zero. Pour out the water from the beaker, leaving the gold mud behind. Add distilled water, heat it on a flame, and evaporate all the liquid to leave dry gold powder, which should be the gold we're after. But judging by its appearance alone, it doesn't seem to resemble gold at all, right? Don't worry. Place all this gold powder back into the dry wok and heat it until it melts completely. Once fully melted, pour the liquid into a mold and wait for it to cool. You'll then see something familiar. Isn't it impressive? It seems this refining method didn't go wrong. So, how much gold did we ultimately extract from this 533-gram ore? Let's weigh it. The final result is approximately 213 grams of pure gold. However, after measuring, the purity of this gold is only 0.9999%. While this purity doesn't match the 0.999949s of 24K pure gold, it's still an excellent level. Looking at this chart, 24K pure gold is about 0.9999 purity, while 23K is 95.8%. So, this 0.99 gold block, with over 99% purity, is already better than 23K. However, the final weight is only 213 grams, which is 9 grams less than the initially estimated 222 grams. What is your thought?